Very good evening to all the 11th standard students of St. John's. Yesterday we have completed the topic called vector algebra, right? In which we have seen first definition of vector, what is meant by a vector quantity, what is meant by a scalar quantity we have seen. And after that, few properties of a vector we have discussed, what are the properties that a vector will have. And we went on to see what is meant by direction ratio and the direction cosines of a given particular vector and how to calculate direction cosines using modulus of a vector and all we have seen. Then we moved on to a crucial topic called product of vectors, and which is classified into two types. One is scalar product or otherwise called as dot product, and the second one is vector product or otherwise called as cross product. And in each type we have elaborately discussed about the properties and also related problems we have discussed, right? And we have completed the chapter yesterday, 8th chapter. Now, leaving 9th chapter, we will move on to chapter number 10 called differential calculus, differentiability and methods of differentiation. And in this topic particularly, we are going to discuss about what is the meaning of differential calculus and what is how to differentiate and what are the methods available in differentiating. Now, what is the meaning of differentiation? Differentiation is nothing but rate of change of a particular thing with respect to some other thing. For example, if you start walking, initially you will cover zero distance, right? So when you start moving, the time starts counting, right? When the time goes on, when you keep on moving, definitely you will cover a distance. So there is a rate of change in the distance covered by you when the time goes on. So differential calculus is very important topic in real life, which calculates the rate of change of a particular substance with respect to some other thing, which is very helpful in solving real life problems also. Again I repeat, what is the meaning of differentiation? It is a rate of change of a particular thing with respect to some other thing. For example, usually we will denote the differentiation like this. For example, dy by dx. Suppose I am writing dy by dx. What is the meaning? Now I am going to give meaning for y as, let us take y as displacement or distance covered. Let y be the distance. I'll just rub this and write dt. dt. So what is t? T represents time. So y means distance covered, t means time. So what is the meaning for dy by dt? The meaning for dy by dt is the rate of change of y. I want you to listen very carefully. The initial stages, if you listen and observe and clearly understood the meaning, the chapter goes on smoothly. Otherwise, many students will feel that it may be a difficult chapter for many. So, everything lies on how you are listening at the initial stages. Okay. Now, dy by dt, what is the meaning? Rate of change of y. What is the name given for y? Y means distance. Okay. Now, I can call this as rate of change of distance with respect to time. Rate of change of distance with respect to time. That is the first example I have given. When you start moving from a point and you keep on covering a distance and the time goes on, definitely after some time you will cover some particular distance. So what is the meaning? There is a rate of change of distance when the time progresses. So when the time progresses, you may cover more distance. When the time keeps on going, you may cover more distance. Calculating those rate of changes is called differentiating or calculating the differentiation. Again I repeat, dy by dt. What is the meaning? If I write like this, this is the meaning of, this is differentiation. What is the meaning? Rate of change of y with respect to time. For example, suppose if I am writing dy by dx, immediately what you will say? This is nothing but rate of change of y with respect to x. Y and x may be anything, but we are calculating the rate of change of numerator with respect to the denominator. And you know very well, you might have studied in your physics also, a rate of change of distance with respect to time is nothing but velocity. Yes or no? Velocity means dy by dt. What is the actual meaning? There is a movement in the object. The object starts covering some distance when the time progresses. That is called velocity. So there is a indirect name for this. What is? In physics we will learn this as velocity. Suppose, again you might have learned, if I differentiate, if I go for one more rate of change, d square y by dt square, this may be come under acceleration. So these are all the things that you have learned in physics. But for time being, what we should know is dy by dt is nothing but rate of change of y with respect to time. Rate of change of y with respect to x. Hope you have understood what is the concept of differentiation. Differentiation is nothing but rate of change of a certain quantity with respect to some other quantity. So it is very important in this lifetime to calculate the rate of changes. Okay. Now in this chapter we are going to learn some basic formulas which they have already calculated and kept for us. We are going to learn all those formulas manually without proof, and we are going to apply it in some theoretical problems as well as practical problems also. Especially this chapter will have only problems, theoretical problems, which we can do easily when we know the basic differentiation formulas. So we are going to go and see what is the basic differentiation formulas, and when you see the video you just see what are the differentiation formulas given to you, and after seeing that you write it out, and first and foremost thing you do is first memorize all those formulas. 21 formulas or only 21 or 22 formulas will be there. So if you read all those things, the next classes will become much more easier for you. And before going into the formula, we will discuss few more things. And the chapter name is Differential Calculus. So what we are going to do? We are going to do some algebraic operations on differentiation. That is what we are going to do in this chapter. Doing some algebraic work on differentiation. Differentiability. Differentiability means, what is the meaning of saying differentiability? That is we are going to see in this chapter. Methods of differentiation. What are the methods available to differentiate? Many rules are available. Product rule, quotient rule, and sum rule, or left hand rule, right hand rule. Many rules are available here. So that are all we are going to see. So entirely this topic is very important topic. So it is very important that you should give utmost care at the initial stages. Yes, now we will pass on for seeing the basic differentiation formulas. So first we will see all these. This is called, I said, no, basic differentiation formulas. We will see one by one. So when we see tabular column contains two columns. One is function, other one is derivatives. Derivative means rate of change of the function. What is the meaning of derivative? Calculating the rate of change. So constant k, when we differentiate, when we calculate the derivative, answer is 0. So these are the things you should keep in your mind, should be kept in your mind for a long period of time. Whenever, till you complete your studies, these formulas are going to help you a lot. Differentiation of a constant k, the answer is 0. Because there is no rate of change. Constant is fixed, so it will not change. So the differentiation process will not be there. So answer becomes 0. And formula number 2, x to the power of n. If we have a function like this, then the derivative is given by n into x to the power of n minus 1. So this is our function x power n. How to differentiate? Just bring the power before and reduce the power by 1. That is the meaning. Bringing the power before and reducing the power by 1, n minus 1. n into x to the power of n minus 1. An exponential function If you differentiate it, there will not be any change. Same e power x will come. These are all proofs are given in our textbook, but it is not needed for the examination point of view. So you can just read this as a manual formulas. E power x, e power x. If we differentiate a to the power of x, the answer will be a to the power x log a. When we differentiate log x, answer is 1 by x. If you want the proof, you can refer your textbook also. X to the power of n, what is the formula? N into x to the power of n minus 1. E power x, same e power x. A power x means a power x log a. When we differentiate logarithm, that is log x, the answer is 1 by x. And this is called as product rule, u dot v. When we differentiate two functions which are in multiplication, which are in product, then we will use product rule of differentiation. The answer is u into v dash, just listen how I am reading it, u into v dash plus v into u dash. The meaning of dash stands for differentiation. The meaning is you keep u as it is, differentiate v, that is why I have written v dash. What is the meaning of v dash? Differentiating v plus keep v now. U and v are two functions which is present in product. So v into u dash. What is the meaning of u dash? Differentiating u. So this formula is called product rule of differentiation. And the next one, u by v. U by v. It is called quotient rule for differentiation. Quotient rule for differentiation, the formula is v into u dash minus u into v dash by v square. How I am reading it? V into u dash minus u into v dash by v square. So this is the formula which is called quotient rule of differentiation. When two functions are present in quotients like this, we should only apply this method to differentiate that type of function. So denominator carries v square. What is numerator? It starts with v, not u. V into u dash minus u into v dash by v square. Then trigonometric functions are given. Sin x, when we calculate the rate of change of sin x, the answer will be cos x. If we differentiate sin x, the answer is cos x. When we differentiate cos x, answer is minus sin x. And differentiation of tan x, answer is secant square x. So these three are nothing but differentiation of trigonometric functions. So all these formulas we have to memorize first. Without memorizing, we cannot go to next video and see the problems which is explained to you. Only if you are thorough with all these formulas, you can boldly enter into the problem section. So it is necessary, it is mandatory for you that first write all these things clearly in your classwork. Draw the table like this. First, after drawing the table and completing the writing the formulas, definitely you should learn the formulas first. And we have few more formulas to be learned, and I will show you the next formulas. And the function from formula number 11, secant x, and we differentiate secant x. The answer is secant x into tan x. Secant x, when you differentiate, answer is secant x into tan x. Again, these are all trigonometric differentiation. Cosecant x minus cosecant x into cot x. Secant x means secant x into tan x. Cosecant x means minus cosecant x into cot x. Cot x, answer differentiation answer is minus cosecant square x. Cot x differentiation is minus cosecant square x. Then inverse trigonometric functions, sin inverse, cos inverse, tan inverse, cot inverse, secant inverse, cosecant inverse. Another 6 are there. So we will see one by one. First, sin inverse x and the differentiation formula is x. When we differentiate sin inverse x, the answer is 1 by root of 1 minus x square. This is denominator. 1 by root of 1 minus x square. Cos inverse x, answer is same but with minus sign. Minus 1 by root of 1 minus x square. When we differentiate tan inverse x, answer is 1 by 1 plus x square. 1 by 1 plus x square. cot inverse x. Again, the difference is only the minus sign. If you compare sin inverse and cos inverse, the difference stands for only minus sign. Tan inverse, cot inverse also, the difference is only with this minus sign. Tan inverse means plus 1 by 1 plus x square. Cot inverse minus 1 by 1 plus x square. Secant inverse x, 1 by x into root of x square minus 1. What? 1 by x into root of x square minus 1. Don't get confused with other things. This is totally different. Secant inverse x means 1 by x into inside root which comes first, x square minus 1. Similarly, cosecant inverse x, same thing, extra one minus symbol, minus 1 by x into root of x square minus 1. And 20th one, 1 by x, when we differentiate 1 by x, answer is minus 1 by x square. When we differentiate 1 by x square, which is written as 21st formula, the answer is minus 2 by x cube. Suppose if I want to write one more, I am writing 22nd. Suppose if I want to differentiate 1 by x cube, the answer is minus 3 divided by x to the power of 4. So you can see some pattern while you see all these three. 1 by x minus 1 by x. Here x means x square. If it is x square, here it is x cube. X cube means x power 4. And again if you see x square means minus 2. X cube means minus 3. So immediately I can ask you one question. What is the answer for 1 by x power 4? Can you say? If you can able to tell immediately, then you are memorized the formulas thoroughly. That is the meaning. Answer for 1 by x power 4. The answer is minus 4 by x to the power of 5. Even if I say 1 by x power 100, immediately I can say the answer as what? Minus 100 divided by 1 x to the power of 101. Is it right? 1 by x power 100. What is the differentiation answer? Minus x to the power of 100. Is it right? Minus 100 by x to the power of 101. For example, I will write here. Suppose I am writing 1 by x to the power of 100. I want answer for this. When comparing this relatively, can you tell the answer for this? The answer is minus 100 by x to the power of 101. So likewise, you can list many formulas. So these are the basic up to 21. Or even you can add this 22nd. Up to 22nd formula, they are called basic differentiation formulas, without which we cannot go to further level. So it is very important that you should learn all these 22 formulas thoroughly. At any time, if a question is asked what is the differentiation answer for anything, you should be able to immediately deliver what is the correct answer. If so, the problems becomes very easy for you. And we will see few more examples in seeing the formulas. Now, for example, now we will see a simple example now. First formula that we have learned is x power n. Constant, of course, constant when we differentiate, answer is 0. We will leave it. And the next formula we have learned, basic formula, x power n is written as n into x to the power of n minus 1. So how to apply this formula when a function comes of power type? Suppose for example x power 10. How to apply this formula? According to this formula, what should I do? How to differentiate this x power 10 and use this formula now? X power 10 comes before, right? 10 comes before, power comes before, and the power gets reduced by 1. So 10 becomes 9. Power comes to the front and the power gets reduced by 1. So x power 10, answer is 10 into x to the power of 9. Power gets reduced by 1. Suppose if it is x to the power of 1000, what is the answer now? Power comes to the front, 1000, x to the power of 999. Power gets reduced by 1. So this is a very simple example that is given for the first formula, basic formula, x to the power of n. Okay. Now we will go for another one. You can answer all the time whether x power 10, x power 5 alone will come. Will there any coefficients if joined? What we have to do? We will take one more simple example. Again, I am going to write the same formula. X power n means n into x to the power of n minus 1. I said x power 10 means we can easily apply the formula and find out the answer. Suppose if it is 5x power 10, then what we have to do? X power 10 means you can easily say answer is 10 into x to the power of 9. Suppose if it is 5x to the power of 10. Now how to apply this formula in this sort of a situation? And before seeing this, I want an answer for this also. What is the differentiation of x? What is the differentiation of x? Which formula I have to apply to find the answer for differentiation of x? Can I use this formula, x to the power of n formula here? If so, what is the value of n? There is no power, so I have to think 1 is present there. Yes or no? X power n, here it is x power 1. So use this formula now. X power n, what we have to do? Bring the power to the front. So I have brought 1 before. Power gets reduced by 1, I said. So x to the power of 0. Because already 1 is present, if it gets reduced by 1, becomes 0. You know very well, x to the power of 0, answer is 1. So totally 1 into, this is also 1, finally answer is 1. From this we have to understand one thing very clearly. The differentiation of x, answer is 1. Is it clear? Differentiation of x, what is the answer? Answer is 1. Because using the same formula that we have studied now. X power n into x power n minus 1. What is differentiation of x? 1. What is differentiation of x power 10? 10 into x power 9. What is differentiation of x power 5? 5 into x power 4. Differentiation of x power 3? 3 into x power 2. Same way, suppose if it is 5x to whole power 10, what I have to do? Listen very carefully. This will help you to do the problems by yourself. 5x to the power of 10. Now I am going to apply the same formula x power n even for this situation also. Which means, what is the meaning? In my mind, I am thinking that this 5x is nothing but x. Yes or no? This 5x, I am treating in my mind 5x as x. Then only I can apply this formula. So apply the formula now. What happens? Power comes to the front. 10 into 5x x power n minus 1. So 5x to the power of 9. So imagine this formula in my mind. I have written the answer for this. Bringing the power to the front. Reducing the power by 1. This is the answer. Suppose if I say this is the final answer, it is wrong. What is missing here? Why this answer is not correct? The only thing is, in formula we have x power n, but here in place of x we are having some other term, 5x. In place of x I am having some other term present, 5x is present. If it is the case, just applying the formula alone is not enough. Additionally, we have to do one thing. What we have to do is, which one I am considered in my mind as x, 5x. I should differentiate that 5x once again. Is it clear? This is the very important concept you should know. X power n formula I have applied, but in place of x, 5x is present. No, need not worry, apply the same formula, but additionally, you differentiate this 5x once again. Once again, we have to differentiate 5x. How to differentiate 5x? 5 will remain. Just now I said, what is the differentiation of x? 1. So differentiation of 5x is 5. What is differentiation of 3x? 3. Differentiation of 7x? 7. Differentiation of x? 1. Differentiation of 10x? 10. So we should know this. So this is not the final answer. I have to differentiate 5x once again. If I differentiate 5x, 5 will come. I should multiply that 5 with this answer. Then only the answer gets completed. I think you will still have few confusion. So the final answer is 50 into 5x to the power of 9. This is the correct answer. I will take one more example like this for the better understanding. Suppose if it is 7x to the power 5. Immediately what you will do? You will go for x power n formula. X power n formula means blindly what I will do? Bring the power before 5. Reduce the power by 1. 4. I will write this. But this is not completed as well. What should we do to make it complete? Differentiate 7x once again. 7 will come. Multiply that 7 with this. So answer is 35 into 7x to the power of 4 will be the correct answer. One more example. 2x power 10. What is the answer immediately? First step is bringing 10 to the front. Reducing the power by 1. This is not completed answer. What should I do? Differentiate 2x once again. 2 will come. Multiply the 2 with this. So 20 into 2x to the power of 9 is the correct answer. I think now you will understand what I am trying to say. So this is how we have to do when there is some other term in place of x. If we go for a few more examples, you will understand very clearly, I think. So now we will do like this. We will go for the next formula, sin x. Not next formula, trigonometric formula. Sin x, what is the answer? If you see the table, you might know. Sin x differentiation answer is cos x. Now suppose if sin 7x is present, then what should I do? Now I am just observing. I know the formula sin x, if I differentiate, answer is cos x. Here it is sin 7x, which means in place of x, I am having 7x. So I am imagining 7x as x. So apply the same formula now. So answer will be cos 7x. Sin 7x means cos 7x. But the answer is incomplete. What should I do? What is present in place of x? 7x. You differentiate that once again. 7x differentiation answer is 7. Just add that in multiplication. 7 cos 7x is the correct answer. Suppose if it is sin 3x. What is the answer? By formula answer is cos 3x. But in place of x, 3x is present. So 3 should come in the front. 3 cos 3x. And spending more time because I already told you initial stages you should be very thorough with. Then only in problems we can go fast. Here you should spend time. Suppose this is the formula that I know. E power x. If I differentiate, answer is e power x. E power 4x, what should I do? Apply the same formula. E power x means e power x. E power 4x means e power 4x. But in place of x, I am now having 4x. So in that case, differentiate this 4x once again. 4 will come. You just write that in multiplication. 4 e power 4x is the correct answer. So similarly, in all cases, we have to do like that only. For example, suppose if I am having a mixed number of terms, now we will go for a simple problem. For example, let a function is given to us, y is equal to some x cube plus 5x square plus sin x. Suppose if this is the function, and the question is differentiate this with respect to x. So now I want to find out what is dy by dx. What is the meaning of dy by dx? Beginning itself I said differentiation of y with respect to x. Differentiation of y with respect to x. Now this is y. This is called what? Y. Now I am going to differentiate this term with respect to x. Now immediately tell what is the formula for x power 3. Power will come to the front. Power gets reduced by 1. So x cube answer is 3x square plus 5 constant which is so it will remain, 5 will remain. What is the differentiation of x power 2? 2 will come to the front, 2x power 1. Yes or no? 2x power 1. Already 5 is present, so this 5 will become 10x. Power comes to the front, so 5 becomes 10. Power gets reduced by 1, so 1. 10x plus differentiation of sin x, cos x. Differentiation of sin x is cos x. So we have differentiated this entire term with respect to x. So this is the basic concept of differentiation. If you thorough with all the formulas, then we will further pass on to the problems related with differentiation. Thank you, children.